Cool. Ready to go? All right. So this is Trust You Might Have Missed. Last session. This is my first time at 44Con. It's been awesome. So I hope to come back next year. It's been a great experience. I'm actually from Seattle, out in the US, so it was a little bit of a flight, but happy to be here, and hopefully you guys find this interesting. And now there we go. Okay, so my name is Will Schroeder. My handle on Twitter is Harmjoy. I'm a co-founder of the PowerShell Empire and Python Empire projects, Power Tools. Wrote a good chunk of the Veil framework for AV evasion. If people aren't aware, the Empire projects are kind of an asynchronous agent built in PowerShell and Python. We're actually doing a code base combine right now. We've got some really cool stuff coming out in the next week or two. If you're interested in any of that, please talk to me after. I will geek out about it forever. I'm also a PowerSploit developer, which is kind of the gold standard for PowerShell post-exploitation toolkits. I participated in a tool called Bloodhound, which is kind of an Active Directory analysis tool, which I have a few slides on here, which I'll go over. It was released about a month or two ago. I'm a PowerShell Microsoft MVP, and I work for a company called Varus Group in a subgroup called the Adaptive Threat Division. We do a lot of pen testing, red teaming, we're a consultancy. We do a little bit of R&D, and we're kind of a good concentration of offensive and defensive PowerShell, which I'll go over heavily during this presentation. So, first warning, this presentation has no exploits, it has no zero-day. It's all about operational usage. My goal with this presentation is to explain domain trust to everybody and show how you can understand them, enumerate them, and abuse them in your kind of offensive engagements. And this doesn't, the goal here is, instead of just things that might have taken, weeks to months to do previously, I want to show you how to do them in a few hours or a few days at most. So you can actually do these even on more limited time frame engagements. So I'm going to go over a little bit of red teaming, just a couple of slides of kind of explaining what we mean by red teaming, kind of our definition of the term. We're not saying it's right, but kind of how we view it. I'll do a little bit of Active Directory and then kind of explain trust at a reasonably kind of in-depth level of exactly what trust mean as far as the Kerberos communications and all those components. I'm going to go over a little bit of old school enumeration and then heavily dive into new school enumeration with a tool called PowerView, which, has anyone ever used PowerView? A few hands? A few? Okay, awesome. A lot more than I thought. So I'm the primary author of that tool set, and a lot of the components in this presentation will show the PowerView usage to do these domain enumeration and trust enumeration components. Then I'll go over how you can actually map, enumerate, visualize, and abuse domain trust on engagements. I'll have about 7 or 8 slides on Bloodhound and how Bloodhound has started to integrate domain trust into its schema and how you can actually use this to do its analysis. I'll go over some really awesome Mimikatz stuff that I know a few people are familiar with, but not everyone is, as far as some crazy SID history hopping and golden referral trust tickets and things like that. And then if I have time, I know this is the last session, so I can be a little loose on timing. I'll try to go over a couple-minute demo showing, compromising multiple parts of a domain in a forest and hopping across an external trust and things like that. So red teaming, we like to use the term bridging the gap because we like to think, we try to take some traditional red teaming tradecraft and build tool sets that let you use them in even more limited time frame engagements like I mentioned. We know that red teaming is kind of a loaded term. Marketing has kind of taken over with this, like a lot of you know, so what do you mean by red teaming? Originally, red teaming was defined as an independent group that challenges an organization to prove its effectiveness. You were supposed to kind of be a devil's advocate and challenge assumptions. This really started to morph into the network side in kind of the United States and a few other countries to do this kind of operational network adversarial engagements to where you're simulating a lot of the actions of an adversary in a particular network. A lot of people define it a bit differently. Some people say a lot of physical components, a lot of in-person SE, exploit development. People have different views of the term. We take more of kind of an NSA red team type model to where we heavily focus towards more long-running remote network type operations with a focus on Windows. We try to reflect the landscape out there. Most environments have a ton of Windows, so that tends to be what we focus on. I really like this quote. This is from the Microsoft Office 365 red teaming white paper. It's a quote by Michael Hayden, who was the former director of the CIA and NSA. And he likes to say that fundamentally, if someone wants to get in, they're getting in. Accept it. What we tell clients is, number one, you're in the fight, whether you thought you were or not, and number two, you're almost certainly penetrated. So this is really kind of a move towards the assume breach type of mentality that we try to preach. That it's not just about getting one exploit on the border, it's about what happens after that and how you segment everything with defense in depth to try to prevent it. Really good paper, the Office 365 Red Teaming white paper from Microsoft. It's really, really, really good. So highly recommend you guys reading it if you haven't already. So domain trusts have existed for a long time, like since Windows domains have existed. And red teams have been abusing them for a very long time as well. But when I started red teaming or kind of pen testing a few years ago, 2 or 3 years ago, realized there wasn't a lot of information about domain trust from an offensive perspective. And it took me a while to try to figure out why this was the case. My theory is a lot of these actions used to be very time and effort intensive. So they were kind of relegated to large internal or government type teams, to where if you had dozens of people in months of time, then you could actually do this mapping, enumeration, and exploitation kind of at scale. But if you were a smaller team or you just had 2 or 3 guys for a few weeks or maybe a month, it was a lot more difficult to do these types of actions in a constrained time frame. Also, pretty much all these techniques are, you can execute them through multiple means. You can use PowerShell, you can use VBScript, you can use native tools. We like the term offense in depth. We don't want to put all of our eggs in one basket. We're a very, very heavy PowerShell shop. But if PowerShell is blocked or for some reason these things aren't working, you need to have multiple ways to execute these actions. So I will focus on PowerShell in this presentation just because it's Microsoft's post-exploitation language and it makes a lot of these actions very, very easy. But it's not like you can only do this through PowerShell. All right, a little bit on domain trust. Quick refresher on kind of what trust actually mean as far as Active Directory goes. So Active Directory overview, I assume pretty much everyone knows what AD is. This is the only slide specifically on kind of domains, whatever. Logical group of network objects, trees, forests. It's just a way to kind of take all these resources and manage them at scale, right? The main point here I want to focus on is the domain is not the trust boundary, the forest is. This has been known for a long, long time. Microsoft has said this for a long, long time. Lots of people don't properly understand this, and they've architected their networks in a way that they assume a domain is a security boundary, not the forest. And this will come into play at the end with some Mimikat stuff. I'll have to admit, when I started, even just a year or 2 ago, I didn't really properly understand this. So I really want to focus that the domain is not the formal trust or security boundary, the forest is. All right, so what are domain trusts? A lot of people kind of view trust as magic. When on my first red team, my boss was like, just go enumerate these trusts and do things. I had no idea what was going on. It's like I didn't understand actually how they worked under the hood. So trust allow domains to form interconnected relationships. All a trust actually does, underneath all of it, is it links up the authentication systems of 2 domains, specifically 2 domain controllers or the primary domain controllers between 2 domains. And it allows authentication traffic to flow between them. This is done by exchanging an inter-realm trust key. They do a key negotiation based on original password, which I'll go into here in a second. And then they're allowed to exchange these referral tickets as far as Kerberos traffic goes. It's also possible to use NTLM kind of with the trust component. I'm not going to go over the NTLM side. I'm just going to go over the Kerberos side. Forests can also establish trust relationships. These aren't quite as common, but they do exist. And I'll go over the differences of forest and domain and parent-child and all those kind of trusts here in just a little bit. An example with the forest trust, all domains in forest A will trust all the domains in forest B. Make sense? More or less, kind of, a little bit. So communication in this trust, as far as Kerberos goes, works through a system of referrals. So if a user or computer in one domain requests a service ticket for a service or system or resource in another domain, then the domain controller in the originating domain will issue a referral ticket to the forest KDC, the Key Distribution Center, or the trusted domain KDC. It returns a referral ticket. The original requester sees the referral ticket and then is referred to the KDC and the domain it's requesting. So access is passed around through encrypted referral ticket granting tickets that are signed with an inter-realm trust key that I mentioned, which will come into play in a little bit. So there's a lot of configuration topologies that are available that will determine the exact behavior of these trusts. And I'm going to go over the differences of one-way, two-way, transitive, non-transitive, and all those kind of components. So I know it's probably really hard to see. I'm going to post these slides and tweet out a link to them on SlideShare right after this presentation. But Kerberos is a hard thing to wrap your head around. It's not as complicated as, it's really not that complicated, but it's really hard to grasp, and it took me a long time to kind of get my head around it. But in general, this process, if you're a user, you're going to authenticate to your domain controller with your NTLM hash, and you're going to request a ticket granting ticket. The ticket granting ticket is going to be returned, signed and encrypted with the KRB TGT hash, the Kerberos ticket granting ticket service hash from your originating DC. That little bit of information is going to say, I am who I say I am in domain 1. Then, if you request a service ticket for a server in another domain, the process that's executed is you're going to go to your DC and say, I want to access the server. The DC looks and says, OK, the server isn't in my realm, but it's in a realm of a component that I trust. And it's going to return a ticket granting ticket referral ticket that's encrypted with that inner realm trust key, that key that's exchanged with this two-way trust between DC1 and DC2. You get that referral ticket, you're referred back to the second DC in this other domain, and you're going to do a service ticket, a TGS request, and you're going to present that referral ticket that proves it proves to the second domain controller saying, the first domain controller verified I am who I say I am, and it's signed with the key that you exchanged, so therefore, DC2 is going to trust that ticket that was returned by DC1. Then it issues the service ticket encrypted with the server's account hash, and then you have access. So now that was like a really quick explanation for a really complex topic, but if anyone wants to talk about this after the talk, I'm happy to try to explain it a little bit further. One of the things that tripped me up a lot when I started doing trust is the direction of the trust versus the direction of potential access. So if you have a domain that trusts another one, you have the direction of the trust. That means that the trusted domain might have some type of access into the trusting domain. So when you enumerate these types of trusts and you look at the directionality of these relationships, you have to remember, OK, I need to flip this in my head because this domain trusts this, so that domain might have some kind of access into here. So the tools that we write as far as the visualization goes, we flip this around for you so you can actually look at the direction of the access, because that's what we care about as far as offensive and defensive people. There's a link with a little bit more information from Microsoft explaining these types of directionality relationships. So there's a few varieties of trust. You can have one-way trust and two-way trust. And two-way trusts are essentially just two one-way trusts, to where if A has a two-way trust with B, then A trusts B and B trusts A. You can also have transitive and non-transitive trust. So if it's non-transitive, A trusts B, but anything that B trusts, A doesn't trust. But if it's transitive, and if A trusts B and B trusts C, then A also trusts C. Also, something to remember is that a child domain retains an implicit two-way transitive trust relationship with its parent. So every domain within a forest is implicitly, automatically, by default, going to be a two-way transitive trust, which is really, really nice for us, and it gives us some nice exploitation opportunities that we can take advantage of. Again, another TechNet link. Pretty much the only information out there that I know of as far as trust goes is pretty much Microsoft documentation, which is often hard to read, and they have versions for domain functional level 2000, 2003, 2008, and 2012 that vary. I put out several blog posts on my blog.harmjoy.net to try to explain some of these topics in more depth. And also Sean Metcalf, who I'll talk about here in a little bit, his blog adsecurity.org has some really good information as far as Active Directory goes, and he touches on trust occasionally. There's also another couple, like the specific types of trust. You can have parent-child within a forest. You can have external trust, which we'll go over, and that introduces some security protections like SID filtering. And you can have crosslink. All crosslink means is within a forest, if you have a bunch of child domains nested all the way down these leaves, if one wants to talk to the other, the referrals have to go all the way back up through the forest root and all the way back down. So a crosslink allows two child domains to exchange a key to speed up communication. So if you have your forest root is in the United States and you have a geographically distributed Active Directory architecture, crosslinks will keep those tickets from having to transit the Atlantic Ocean every single time that someone wants to access a resource. So why should you care about domain trust? Why should you give a crap? Trust can introduce unintentional avenues of access into a target. Red teams often compromise accounts or machines in a domain that's actually trusted by their target. We do this very, very frequently, to where maybe you phish or you target, like a development domain, NGOs, some kind of dirtier stuff like an R&D domain or something like that. And then you can use that access if there's a trust and actually use it to facilitate compromise into the more secure component in the entire environment. And also for persistence. If you're a pretty advanced red team and you know that the targeted domain that you're going after has a lot more like monitoring, filtering, maybe you leave your persistence mechanism in a trusting or trusted domain all the way down that has very fewer protections. And then at will, you can come back in, seed your access, and then hop back across the trust and compromise whatever your target is. And enterprise admin is a component that comes into forests. So there's one group, enterprise admin in a forest. It exists at the forest root all the way to the top of the trust tree. And automatically, by default, anyone in enterprise admin has administrative access to everything in the entire forest. So it's quite nice. But at a minimum, even if you don't have enterprise admin, you have a trust, internal, external, whatever, you can query information from Active Directory in the domain you have a trust with. So it seems like it might not be that huge of a deal, but we use this all the time, to where you can query anything from Active Directory, the groups, the memberships, the GPOs, the OUs, anything across a trust boundary. And PowerView has a lot of really cool stuff that facilitates this action and keeps you from having to remember all this weird syntax every single time. Cool. So trust enumeration. I'm going to go over the enumeration a bit first, and then we'll get into some exploitation, visualization, and all that. So old school. Who's run NL test? Anybody? A few people? All right. NL test, it was great. That's how I started. The output sucks. You have to parse text. This is where PowerShell can really, really provide some advantages, because you can do really nice pipelining operations and do some really nice chain functionality. But NL test still will return the same information. NL test trusted, NL test /domain_trust. You see in the example, you have, sub.test.local and test.local. Also, if you use the third-party tool ADFind, which is kind of like, a DS query, LDAP type of enumeration, you can do the kind of like nested trust enumeration. Like, okay, I have a trust with that foreign domain. Let me query that LDAP and figure out what it trusts. Now, you see the syntax, ADFind, the distinguished name, you have to do the object class, trust partner, flat name, trust direction. These are the types of things I don't remember off the top of my head. So you either have to have them in a wiki, you have to have them recorded. And these types of actions were started to facilitate started to motivate why we built PowerView, because we didn't want to have to remember all this syntax every single time that we did these things. So keep talking about PowerView. It's a PowerShell domain and network situation awareness tool. I like to describe it as DS query kind of on steroids and cocaine. It was built to automate a large chunk of the kind of red teaming and pen testing tradecraft that we started to adopt that was kind of influenced or based on this kind of military red teaming type of methodology. It's integrated into PowerSploit now. It's bounced around 3 or 4 repos. If you guys have used it, I'm sure some people are probably annoyed at me because it seems like it keeps changing location every 3 months. But it has settled into the PowerSploit repository. The most recent, kind of up-to-date bleeding edge version is always going to be in the development branch of PowerSploit. I promise it will not move again. It's going to be in the development branch for a while. We know dev is pretty far ahead of master. We're going to be doing some revamps to PowerSploit in the next few months, and we're going to try to kind of speed up that merge process, and things should get updated a lot quicker. It's also it's an entirely self-contained, single file, version 2.0 compliant PowerShell script. So we care about 2.0 because we don't want to make assumptions about the machines we land on. So if we land on Windows 7, we want to make sure whatever we have runs. It doesn't install anything. It doesn't drop files to disk. It uses a bunch of reflection tricks to keep from doing embedded add type, C# type stuff. So we care very much about OPSEC, and we try to build our tools accordingly. So just a couple references for you guys for commandlets or functions in PowerView that are useful for trust, right when you land. Getnet forest will return information about the current forest. Getnet forest domain will return all the domains in the current forest. And Getnet domain trust is essentially our PowerShell equivalent of NL test. It'll return all the current trust relationships for the current domain that you reside in. And this also accepts a dash domain flag, which I'll go over in a second. And getNet forest trust will grab all the forest trust, which is a slightly different enumeration, so it has to be separated out to a different commandlet. Like I mentioned, if a trust exists, most functions, not all of them, but most functions in PowerView can accept a -domain flag. And you just provide the foreign domain name, and you get all the information from that foreign domain for whatever the function is. Like getting the domain controllers, the users, computers, groups, group members, file servers, user hunter, all that kind of stuff will work very nicely and easily across a trust if it exists using the -domain flag. Just an example, landing on a machine, doing getNet domain-name, that just shows the fully qualified domain name for where you currently are. And then doing getNet group member, which will unroll the membership of a particular group by default domain administrators. I'm running that across a domain trust to testlab.local while I'm actually in external.local, and I'll return all the members of domain administrators. So pretty nice, like a little bit of recon, a little bit of information. It's really, really useful to have all these functions support this type of cross-domain LDAP type of functionality without having to unroll all the crazy LDAP syntax yourself. So the really cool stuff is map domain trust. So this function will enumerate all the trust that you can possibly reach from your current kind of network position in the domain. And one thing I forgot to mention with these things, you have to run these functions from an authenticated domain user, but it doesn't have to be elevated by default unless they lock down a bunch of ACLs and a bunch of weird stuff, which we really don't see. So you have to be authenticated domain. You can't run this from a non-domain joined Windows machine or Linux machine, but just unprivileged domain user, you can get a whole lot of information. So invoke map domain trust will find all the domain trusts for the current domain, gets all the results, it goes to every single result there and says, okay, give me all the trust for your domain. It has some logic to keep, kind of nested loops from appearing. And it goes, churns on and on and on until it enumerates everything kind of in the trust mesh as we deem it. And you can, the niceness of PowerView is you can just take all the output from this and just pipe it to export tac CSV. Export to CSV, Bloodhound kind of does some of this stuff in the back end and exports it to the Neo4j interface and things I'll go over. So if you export to CSV, the result you might get is something like this. Depending on the size of the organization will depend on the number of domains within the trust. We've seen some clients that have upwards of 1 to 200 reachable domains kind of in their trust mesh, to where we actually understood their networking setup as far as Active Directory went, specifically the trust component. We understood it better than the network engineers because they didn't have a tool at the time that let them visualize and enumerate all this information about what domains trust what. You'll see kind of the trust direction, bidirectional, inbound, outbound. These are those things that when we do the visualization, I'll show you in a second, we flip that around so you know the direction of access. You see parent-child, that's within a forest. You see external, and you see the source and target domain. So this information is nice, but it's raw data. So these mappings are digestible in reasonably small domains. If this is all you have, it's not too bad. But double or triple the size of this and try to map the relationships out, it gets to be a pain. Well, some of the first engagements I was on, I was sitting there with that information and trying to actually take a pen and paper and draw out the entire kind of trust mapping. One of the guys I worked with, Justin Warner, 6dub, was like, this is stupid. Why are you doing this? We're hackers. We don't want to do something manually or do it more than one time. So he built a tool, a Python script called Domain Trust Explorer. It can take the CSV output from invoke map domain trust, and then it converts it to GraphML. So this lets you interpret all these things visually, which is a lot more useful than just kind of the raw CSV data, right? I'm not going to present this to a client, but I might present this to the client. So this is the exact same information, just visualized in a way that you can start to see these patterns and see what you have to do. So say you landed in corp.mothership.com and your target is crownjewels.com. You realize, okay, we need to hop here and exploit these relationships down here, and it lets you kind of map out what your attack path needs to be. So the colors also mean something. Red is parent-child. Green, I always forget. I have it recorded. It's on some of the blog posts I did. Green and blue. Oh, green means external and blue means crosslink. So cool, really nice stuff. Again, you can visualize this, and we use YED, which is a free kind of GraphML mapping component, but you can use it in anything that ingests GraphML. All right, so that's the visualization component. Now we want to actually abuse these trusts. So this is the summary of what we kind of came up as our domain trust attack strategy. First, you want to map all the trusts in their type, whether they're within the forest or otherwise. You definitely want to take note if they're within a forest or external, which I'll get to in a bit. You want to enumerate all the users and groups from one domain that have access to resources in another domain. So trust exists for a reason. Like if you start the trust up, by default, if it's an external trust, it's not going to give you any implicit access. But trust exists for a reason, so people tend to set them up so they can take users or groups from one domain and grant them access to resources or put them in groups in another domain. So we like to kind of call this, you're uncovering the hidden mesh of these kind of accesses that were administrators had set up previously, and they very often set them up incorrectly. Because again, there weren't too many tools that let you kind of audit all these, these nested trust relationships in a way that was like really efficient. So very often we'll see, an old domain that was kind of plugged in, all these relationships are set up with privilege, and then people forget about it and actually don't know how to even enumerate and lock it down until we kind of come in and assess it. Then the last part is you selectively compromise specific target accounts, in that first part where you landed, so you can kind of hop across the trust. So essentially, for kind of the hard way to do it, this is the attack strategy. There's one separate attack strategy if you're within a forest. Like I kept saying, the forest is the boundary, not the domain. There's some really awesome work from Benjamin Delpy and Sean Metcalf, which I'll go over in the last section, which kind of affords you some additional attack opportunities. So if you want to abuse trusted power view, there's 3 functions that are very useful for this for us. So if you want to enumerate all users who are in groups outside of the user's primary domain, i.e. across the trust, you can use find foreign user, either for your current domain or attack domain at the end. This is kind of like a domain's outgoing access. They're users who are in groups not in that domain. Kind of the opposite of that, or the inverse of that, is find foreign group, which are groups with users outside of the group's primary domain. So if we land in a domain, we might use find foreign user to figure out who in that originating domain has access somewhere else. If we're trying to reach a target, we'll use find foreign group on that target to figure out who has access into it and kind of map out those relationships as far as that kind of visualize domain mesh access that we talked about. We also use a lot of getnet local group. This will enumerate the local members of a members of a local group on a remote machine. And for every operating system except Windows 10 Anniversary Edition, you can get this access back as an unprivileged user. So occasionally on like domain controllers or certain select servers, there might be users in a different domain that are granted access to the administrators group or another privileged group on a particular machine. So these are the main functions we use. We've previously done this manually. I'll show you the kind of automated way with Bloodhound here in a little bit. An example with this, find foreign group for this kind of sample domain that I set up. You see, okay, the group name is administrators and external, but it has these foreign security principles from a different domain. And it gives you the SID. So foreign security principles represent security principles from trusted domains external to the forest, and allow foreign security principles to become members of groups within the domain. So it's just a way for these external forest trusts for Active Directory to kind of map, okay, this SID, which is in a domain completely foreign to me, this is kind of how they map all the access and deal with the access control in the back end. All right, Bloodhound. Bloodhound was released about a month or 2 ago at DEF CON this year. It's where all the code went live. You can download it now. It's bit.ly/getbloodhound. It's kind of a web front end to a lot of these Power View components. It does a lot more stuff besides just trust. I'll kind of go over the trust components. But it's a graphing front end built on top of Neo4j with a customized Power View ingester. If anyone has used this, I talked to a few people in the hallways. We're tuning up the ingester so it's a lot more scalable for large-scale domains. We like to think of it as kind of like Google Maps for Active Directory Privesk. And it has a lot of components for offense and defense. You can export all the data to a CSV with the Power View ingester and then ingest it offline to the Bloodhound front end. Or there's also Neo4j RESTful API interface that you can pipe data straight to it. So if your collection box, your pivot box, has access through a port forward or whatever else on the same domain to the analysis server, you can pipe stuff straight there. But very often, if you're operating over a remote pivot, you're probably just going to export to a CSV and download the file. This is what it'll look like. There's a lot of components in these drop-down menus, but in general, you can, like this example, we're unrolling all these nested group memberships for domain administrators. You can search any node in the entire kind of graph, and you can also do pathfinding, which I'll go over in a second. Really, really awesome. We have a guy that did a huge amount of work on the web front end, and we want it to be as usable as possible for everybody. Again, all this is 100% open source, BSD license, so our companies don't own it. It's a free and open source project for everybody. So domains are represented in the schema only for visualizing their relationships, similar to Domain Trust Explorer. So I'll show, the next slide has a screenshot of what that looks like. We went back and forth for a long time, me and the other authors of the project, about how do we model domains in this particular schema as far as the Neo4j backend. The normal schema just has user at whatever the domain is, and for computers, it has machine.domain. So we don't even have to actually model the domains as far as pathfinding goes, because all the information we collect, we just do whatever the user principal names are. And this lets us easily find cross-domain paths without having to do some really crazy modeling in the backend schema component. What do I mean by this? First I'll show you, this is kind of the trust visualization. It's not as nice as that the YED kind of GraphML component, but we're working on it. But it does let you do really kind of basic graph visualization of the similar type of previous slide. The really cool stuff is this. This is a screenshot of an actual network where we use this to where, this is a user that we had access to. This user is a member of this group and this group, which are members of this group, which has access to this machine, which has this person logged in, who can access this machine, and so on and so on and so forth. And every one of these red arrows is a hop across a trust boundary. So we're going from here, we're hopping across 4 to 5 domain trust in a 12-step attack path. And this took about 1 day to collect all the data, and it took 5 seconds to find the attack path. So here, you compromise this machine effectively, compromise here, and you just hop all the way to the end, and here is domain administrators in a really privileged subdomain that we were going after. If we wanted to do this manually, this would have taken us weeks to months, even with kind of the accelerated tool set that we have. But with Bloodhound, we're able to really easily collect this data and hop across these trust boundaries without having to really even worry about it. It's pretty push button. We think it's pretty cool. We're really excited about it. It's one of the cooler projects we put out in the last year or so. There's also some analytics for those foreign group components that I talked about. So pre-built analytics, you can find all the domain admins and shortest paths. There's also users with foreign group memberships. So you collect your entire data set, click the analytic, and it'll show you every single user that has a foreign group kind of domain membership. We're in the process of adding a lot more of these analytics. We're tuning this stuff up. It's a work in progress. The project's only been out for a month or two. But if anyone has any ideas for some cool analytics or better ways to approach the trust boundary components, please talk to me after, email us. We would love to have more participation. All right, now I'm going to get to the coolest stuff. Mimikatz and domain trust. So this work is heavily built. It was done by Gentle Kiwi, obviously, Benjamin Delpy, and Sean Metcalf, who is Pyrotech3 and runs the adsecurity.org blog. Really great. So 2 things that Mimikatz can do that relate to trust. The first, so I mentioned these kind of inner domain trust keys and that whole kind of Kerberos graph, right? So the password for a domain trust account is used to derive an inner realm key for encrypting these referral tickets, like I mentioned. Mimikatz can now extract these trust keys from domain controllers and forge these referral tickets. So if you can extract the key, you can pretend you are whoever you want to be from one domain to the other. So it lets you really easily exploit these relationships. These keys can be used to create these golden trust referral tickets for the KRB TGT service. Now, that inner realm trust key rotates every 30 days. So on average, if you compromise one of these, you're going to have around 15 days to effectively use it, give or take. But if you still retain access on that previous trusted domain, you can keep dumping these keys and forging the referral tickets. So we saw this. We're like, this is pretty cool. It was some pretty cool work, but it wasn't super applicable to some of the stuff we did, simply because that trust key rotates every 15 days. Sean Metcalf saw this, started working with Benjamin last year, kind of at the end of last year, and then he came out with this, which blew my mind when I finally understood what it did. I don't know if you guys saw this tweet. With Benjamin, he's one of my favorite researchers ever. Whenever he releases something new and awesome, he just tweets it with a couple of screenshots, and then nobody realizes the implication of it until months later when people start to digest it. So external SIDs and Mimikatz tickets, same for us, external without filtering, and show some screenshots. So doesn't seem like a huge deal until you realize what it means. So Mimikatz can include extra account SIDs in the SID history component of golden tickets. This attack has been theorized for over a decade, kind of the SID history abuse within a forest. SID history was an Active Directory attribute meant for kind of Active Directory domain migration. So if you move people from one domain to another, you would set the SID history to be what their old security identifier was, and it grants them access to whatever their old resources were. So whatever SID you have in your SID history, you effectively become that user. So if you're a user that has the SID history set to be domain admins, you effectively can be a shadow domain admin even if you're not a member of that group. The problem was, in order to abuse this previously, you had to modify the ntds.dit database on a particular domain within the forest. You know, something that's reasonably destructive. There was allegedly a Russian tool 2 or 3 years ago that did this. I've been trying to find a copy of it for a while. I see some of the docs in like old archive.org, but we can't actually find a copy of it. So I'm sure people have been doing this in the past. But previously, it was extremely difficult and like semi-destructive. You would have to like bring a domain controller down, like edit the NTDS offline, and all that kind of stuff. But with Mimikatz now and golden tickets, you don't have to modify anything. When you create your golden ticket, you just do /SIDs. You do whatever the SID history SID you want it to be, and then you're implicitly granted access with that golden ticket to whatever that SID means. So if you get the KRB TGT hash of any domain controller in the entire forest, any child domain, and you set the SID history to be enterprise admins, so whatever the forest root -519, then you automatically can compromise the forest root. So normally the access and the trust like flows down. If your enterprise admin's at the top, you can access everything. And previously, if we wanted to hop all the way up to the forest root, we would have to do that find foreign group, find foreign user, get in that local group, and like kind of manually hop all the way up. But now with golden tickets, the moment you get any domain admin rights anywhere in the entire forest for 5 minutes, you can compromise every single domain in the entire forest. So we've done this in the field. This blew like, I had to like sit down for like an hour, and I was like, this can't be right, this can't be right. And I DM'd Benjamin, he was like, brain explode, like did I just mess with your mind? I'm like, I don't understand why this is possible. It makes sense now, and again, Microsoft has known this, it's a known attack. There just wasn't a really easy, feasible way to execute it on engagements. But we have done this in the field lots of times, and when you brief it to clients, they kind of are just like 30-second pause and they're like, what? Like, what's the fix? Re-architect your entire Active Directory solution, which would cost $10 million? Like, sorry, like that's pretty much the entire fix. You have a major architectural flaw in how you had assumptions and how you designed your Active Directory schema. If you want to fix it, you need to have proper external trust and not just have a child domain in a different country be a part of the entire forest. It's really awesome. So just a screenshot of the example. I'm creating a golden ticket here. I'm in a child domain. I'm going to set the extra SIDs with that /SIDs parameter to be the SID of the parent domain -519. So that's the SID for enterprise admins. So with the regular golden ticket, if I'm in that child domain, I should be able to access the domain controller in that child domain, dev.testlab.local. That makes sense. But with the extra SIDs, then I can access the domain controller of the forest root instantly without doing anything else, as long as I can communicate with the forest root. If there's crazy network segmentation, then some people think, okay, we network segment, that's the mitigation. Fun fact with domain trust, if your domain trusts another, then the domain controller has to be able to communicate with the trusting domain. So you can just hop domain controller to domain controller if you need to. So there's not really a way to stop it. So if you can compromise one domain controller of a child domain in a forest, you can compromise the entire forest within 5 minutes or less. And Benjamin Delpy's, when someone asked him what the mitigations were for this was what he tweeted back. Keep calm and rebuild the entire forest. So rebuild from scratch, rebuild from bare metal, and re-architect everything is essentially, sadly, the hard part. And one thing I forgot to mention is like one of the only kind of mitigation for golden ticket that's been out there right now, as far as mitigation, not detection, but just mitigation, is rotating the KRB TGT hash for a particular domain. Now, there's a script out there from Microsoft that lets you do that. But with the SID history component, if you want to be secure, you have to rotate the KRB TGT hash of every single domain in your entire forest, not just the forest root. So otherwise, if I'm an attacker, I compromise the forest, let me just DC sync or get the hash of every single KRB TGT in the whole forest, and the odds of an organization rotating every single one of them is relatively low. So I can still have access within 5 minutes to whatever else I want. So a couple of caveats with the SID history component. If there's a security protection called SID filtering. It's enabled by default on external and forest-to-forest trust. So not within the domain, but forest-to-forest and external. So if SID filtering is enabled, the domain controllers in a trusting domain remove the SIDs specifically from SID history that aren't contained in the trusted domain. So it filters out those components. So with SID history, you can't execute this attack because the SID filtering protection will just strip it out. So this prevents this attack, like I mentioned. It's enabled by default for external and inner forest trust. You can also enable it for trust within a forest. So there's quarantine within forest as a particular security protection. So if it's marked as quarantined, this will filter out all SIDs except the enterprise domain controller SID, which is S159. So a lot of people thought, OK, this is a reasonable mitigation of protection. But because it doesn't filter out this one SID, if you do a little bit of trickery and you kind of know what you're doing with the Mimikatz flags, you can still construct a golden ticket in such a way that you're pretending to be an enterprise domain controller trying to facilitate replication, and you can still hop all the way up to the forest root. So it's a lot trickier, but it's still possible. So if any domains are within a forest, there's no way you can protect against the SID hopping attack. Cool. All right, so I'm going to try to show a short, 4 to 5 minute demo to prep it. Say we land on a machine in the dev.testlab domain. We want to compromise the external.local forest. I'm going to walk you through this with invoke Mimikatz, and we'll do this by using trust relationships to hop to testlab and then external. And I'll take some questions. Oh, no, I don't want to do that. I want to do. What? Can I not? Nope, it's not letting me do that. All right, one second. Oh, come on. There we go. OK. Now, if you guys, I tried to make the text as big as I could. Showing here, I have the actual commands kind of scripted out here. So we're landing in Windows 4 and dev.testlab.local. I'm going to load up invoke Mimikatz and load up the Power View component for the enumeration. The first thing I'm going to run is invoke map domain trust. We see that, which would make sense, dev.testlab.local has a parent-child relationship with testlab.local, and testlab has a forest-to-forest trust between them. So dev is parent-child transitive to testlab, and testlab has an external trust to external. So I'm going to run find foreign group on external to see what I want to actually target, what I want to get into. I see a couple of these external security principles. These SIDs don't quite make sense to me, so I'm going to use PowerShell in the pipeline, get all these foreign groups, extract out the SID username, and convert the SID to a name really easily with the pipeline. So we see, OK, testlab Justin Warner is a member of administrators, meaning you would have admin access to the DCs in this external domain. So Justin Warner is the person we want to go after ultimately. So we're going to gather a little bit of information on him, get his user SID, and get his group SID so we can construct the golden ticket in such a way that it perfectly mimics, or reasonably mimics what an actual TGT would be for this user. So got his user SID, got the SIDs of the group he's a part of, which will come into play on the last step. Next, we're going to invoke Mimikatz. So we're going to use DC sync to, in this example, in that dev domain, we're assuming we're domain admin and kind of that dev child domain. So DC sync is a newish feature, about 8 or 9 months old, with Mimikatz, where it can simulate the DC replication protocol from domain controller to domain controller. So from here, instead of having to pop up and actually compromise the NTDS to get hashes, you can just run DC sync. It goes to the domain controller and says, hey, I'm also a domain controller. Can you replicate this information to me? And we can really easily get the hash of the KRB TGT account. Now we're going to map out the SIDs for the child and parent domain, because this is important for kind of the external SID hopping component. So the easy way to do this is KRB TGT always exists. With Power View, I'm just going to convert the short name, whack whatever that is, and convert it to an actual SID for the domain. So I'm going to use the KRB TGT from the child domain that we DC synced. I'm going to set the extra SIDs to be the root SID-519 for enterprise admins, just kind of like that screenshot. So very, very similar. This will do the SID hopping component with the golden ticket and allow us to instantly hop up the trust to compromise the forced root. And /PTT injects the ticket straight into memory instead of exporting it and having to re-inject it. And I'm also using a user that doesn't exist. There's a cool stuff with Mimikatz to where if you can create a ticket for a user that actually doesn't exist in the domain, and if you use it within 20 minutes, it will still facilitate access before some other stuff comes in the back end. So if IR guys are trying to look at this, like this user that didn't exist requested a ticket and somehow compromised the entire forest route, it doesn't quite make sense to them. So I'm showing here that even though I'm in that child domain, just injecting that ticket within 2 minutes, I can instantly compromise, I have admin rights to the primary domain controller in the forest route. From here, I'm going to DC sync the forest route to get the KRB TGT account, because we enumerated that a user in the forest route has some kind of privileged access across the external trust. So run this. We're going to DC sync KRB TGT again. We could also just DC sync the jwarner.a user and do overpass the hash for it, but we want all the access and just some, instead of just some of the access. So we get the NTLM for KRB TGT for the forest route. And it's showing, testlab.local is the domain, primary.testlab.local is the domain controller. I'm going to purge all the existing golden tickets so I just don't get weird kind of cross-access chatter stuff. Then the next step will be we want to create a golden ticket for that privileged user across the external component. So we want to create a ticket that makes us look like jwarner.a, so then we can hop right across that trust. Again, map everything, figure out who has access across the boundaries, and then have a way either through targeted account compromise or golden ticket forgery that then we can create the ticket and just hop right across that external trust. So here, jwarner.a, his ID is a SID, his groups are that, so we're matching all the actual components of what the ticket should look like. Golden ticket for jwarner with no external SIDs here, it just shows the groups match, the user ID matches. So now it looks like we are jwarner.a in the forest route. So from here, that was a mistype, one more command. Because we already enumerated that jwarner had elevated access across to the external domain, we can just DC sync and actually compromise the entire external domain. And again, this whole thing was like 5 minutes for the demo to do a multi-domain hop and compromise an external trust. Cool. Upgrade, did I close? 1 second. Oh, crap. I closed the presentation. All right, that sucks. That's pretty much it. I don't know if there's any questions. I definitely want to thank Benjamin Delpy, Gentle Kiwi, Sean Metcalf, Pyrotech, Waldo, Andy Robbins, the guys that worked on me with Bloodhound, Rohan Vizerker, Justin Warner, 6dub. Again, my handle is Harmjoy on Twitter. My domain is will@harmjoy.net. I write about this stuff on my blog a lot. If anyone has any questions or wants to talk to me after, I'm more than happy to talk about all this stuff. So thank you guys very, very much. I appreciate you guys letting me come out here and hopefully not bore you too much for 45 minutes. So any questions? Yes.